So Josie's on a vacation far away, but that doesn't mean you can't come around and talk it over. And by talk it over, I mean the next troublesome term in chemistry. But listen, first, a heartfelt thank you. I want to personally thank you for subscribing to the channel. We recently exceeded 4,000 subscribers, and I think that's a pretty big deal. So thank you. That little gesture you made of clicking on the subscribe button really helps me build the channel. And again, thank you. So I took a little time away from guillotine chemistry to catch up on some other obligations. I guess you could say I took like a bye week. And I know what you're thinking. Ooh, bye. That would be a really good segue if he was talking about the prefixes bi and di. And you'd be right. So see what I did there? Bye week, right? The prefix bi. Huh? You might say that play on words was to die for. See that? I can't stop. I'll be here all semester. Try the veal. So di and bi. A normal person might think these terms are interchangeable, but as we've said many times, chemists are not normal people, and these terms are no more interchangeable in chemistry than the terms bicycle and dicycle, or bifocals and difocals. You can't switch them around. Although I would like to see a dicycle. I think that would be pretty cool. Got to be better than a hoverboard. And yes, that is another hoverboard slam. I just don't like the fact they don't hover. Got no problem with them otherwise, but you know, it's not hovering. So di has Greek origins, and it means double or two. It comes from the Greek word dis, which means twice. And it is used in chemistry to denote a compound that contains 2 units of a substance. The classic example is carbon dioxide. 1 carbon and 2 oxygens, dioxide. So bi comes from Latin, but it means the same thing, twice or double. But in chemistry, it has a very different connotation. It doesn't mean 2 units of something, it means 2 parts or equivalents of something. And that doesn't mean the same thing. Now, like the prefix di, the prefix bi is also used in nomenclature in, family favorite compounds just like this, sodium bicarbonate. Okay, but you might think that bi means that there's 2 carbonates, but that's not the case at all. Now, I'm telling you right now, you are not going to be satisfied when I tell you what bi means. It will answer almost none of your questions. But nonetheless, bi in front of a polyatomic means that that polyatomic has an H+ ion attached to it. So carbonate, for instance, is CO3 2-. Bicarbonate is HCO3-. That H+ soaks up one of the negative charges. Now, if you want to learn more about polyatomics, I actually have a video that talks about all of the prefixes for polyatomics. I think it's pretty good. And if the only reason you came to this video today was to understand what bi and di actually means, then I guess we're technically done. But if you're willing to stick around, I think actually bicarbonate is a really fascinating little story into the history of chemistry, into a world before we really knew stuff about chemistry. Like again, you and I have grown up in a world where water is synonymous with H2O. Like embedded in us from an early age is the idea that stuff is made up of atoms and atoms make compounds. But that was not always a given. The interesting thing about the term bicarbonate is it harkens back to the early days of atomic theory. It was coined by an English chemist named William Hyde Wollaston. And he was a contemporary of people such as John Dalton, who was at the time trying to establish that first atomic view of matter. I mean, think about this right now. If I put you in a laboratory right now and said, hey, I'll give you a day or 2 to validate the existence of atoms, you'd probably struggle a little bit to do that. I mean, think about how creative these people must have been 2 centuries ago to cobble together whatever equipment they could find to try to elucidate the atomic structure of matter. It's pretty amazing. So Wollaston was looking at 2 very similar compounds that contained both sodium and carbonate. But what he found was in the first compound, for every 10 grams of sodium, it contained about 13 grams of carbonate. But the second compound, for every 10 grams of sodium, it contained 26 grams of carbonate. So from an equivalent point of view, the second compound had twice as much carbonate. And so he called the second compound sodium bicarbonate. So Wollaston was right and wrong, depending on your point of view.
So what I told you was true, from a certain point of view.
A certain point of view?
Luke, you're going to find that many of the truths we cling to depend greatly on our own point of view.
It turns out a better name for sodium bicarbonate would have been half sodium carbonate. And this is the point I tap out and just tell you the formulas. So the polyatomic carbonate has a -2 charge, and that means that it essentially has 2 parking spots for ions such as sodium. So the first compound that Wollaston saw was sodium carbonate, but it was Na2CO3. Each one of those spaces had a sodium in it. The second compound that Wollaston was looking at was sodium bicarbonate. But in this case, the carbonate had 1 sodium and 1 hydrogen. So the hydrogen ions were taking up half the space that sodium usually took up. Now, when you look at these 2 formulas now, it's pretty obvious that they both contain the same amount of carbonate. But remember, Wollaston didn't have that perspective. If Wollaston was comparing these compounds simply by the amount of sodium, then he would need twice as much sodium bicarbonate to get the same amount of sodium as in sodium carbonate, because there was only 1 sodium instead of 2. And so if he doubled the amount of sodium bicarbonate, right, then it looked like there were 2 carbonates because it all scaled up. Like even the governing body of chemistry, the IUPAC, the International Union of Pure and Applied Chemistry, realizes that the prefix bicarbonate is a disaster. What the IUPAC recommends is that we lose the bi and we instead say hydrogen carbonate. So baking soda should be called sodium hydrogen carbonate. And that way you know there's a sodium and a hydrogen and a carbonate. Confusion gone. And using the prefix hydrogen instead of bi actually solves other problems because there are larger polyatomics like phosphate that actually has like 3 parking spots for ions like sodium. So you could theoretically have sodium dihydrogen phosphate. You could have 2 of those spots taken up by hydrogen. You can't do that with the prefix bi. Again, if all you care about is what this stuff means, remember that di means 2 and the prefix bi means there's a hydrogen on the polyatomic. Thank you for indulging me on that historical tangent. I know that was probably really frustrating, and I too find early atomic history very frustrating and also extremely fascinating to try to figure out the way they thought. You could even say my frustration and fascination are equivalent. Stay safe, see you next time. Listen to some Outfield, and have a great day. Rest in peace, Tony Lewis, wherever you are.